Students, good morning. This is part 2, working principle of clad liquefaction process. In this part, I am going to discuss about what is the principle behind in the working of clad liquefaction process. Clear? Right. This is one component 1, compressor. Compressor is used to compress the air near about 200 atmospheric pressure by decreasing its volume. Decreasing volume, which in turn increases the temperature of air to a great extent. Clear? This is compressor. In this type, a reciprocating type compressor is employed. Clear? The compressed air is fed into a cooler. Here, the temperature of air decreased to its room temperature by spraying cold water at the top and warm water is rejected at the bottom. Cooler is used to decrease the temperature of air to its room temperature. Okay. 80% of the main steam is bifurcated to the expander. Here, our ultimate aim is to decrease the compressed air, temperature of compressed air below its critical temperature. Minus 140 degrees Celsius is the critical temperature of air. What happens in this expander? Once air enter into the expander, it expands. That means due to expansion, amount of work done by the air is used to rotate the shaft of the turbine. The amount of work done by the air due to expansion is used to rotate the shaft of the turbine. The turbine shaft is connected with the electric generator. It is used to produce the electrical energy. I am saying during this expansion, the process is reversible. Reversible means amount of work done by the air due to expansion is exactly utilized to produce the electricity. Process is reversible. Moreover, this turbine or expander is completely insulated. There is no way to exchange the heat between system and surrounding. So, reversible adiabatic expansion. This reversible adiabatic expansion is nothing but isentropic expansion. Isentropic expansion. The Joule-Thomson coefficient or isentropic expansion coefficient. Joule-Thomson coefficient or isentropic expansion coefficient is equal to rate of changes in temperature with respect to unit decrease in pressure at constant entropy. Here expansion is isentropic expansion. Clear? Our ultimate aim in expander is to decrease the temperature of air below its critical temperature. It is possible. Clear? Once again, I am repeating the statement. 80% of the main steam is bifurcated to the expander. The ultimate aim is to decrease the temperature of air below its critical temperature. During expansion, amount of work done by the air. Amount of work done by the air due to expansion is used to rotate the shaft of the turbine. The turbine shaft is connected in an electrical generator. The generator produces electricity. Amount of work done by the air due to expansion is exactly converted into electrical work. Hence, the process is reversible. The expander is highly insulated, perfectly insulated. Hence, there is no changes in heat content. There is no way to heat interaction between system and surrounding. Hence, I am saying this is adiabatic. Reversible adiabatic expansion is nothing but isentropic expansion. The isentropic expansion coefficient or Joule-Thomson coefficient is nothing but rate of changes in temperature with respect to unit decrease in pressure at constant temperature. This is the principle involved in one kind of expansion. Clear? Right. What next? The cold outgoing gas, cold outgoing air at low pressure, because it gets expanded. Clear? Gets expanded. Low pressure and low temperature is reunited with the return air from flash drum and fed into a low pressure tube. Leave it. 20% of the remaining main steam. 20% of the remaining main steam is fed into a high pressure low temperature tube, high pressure tube. It is in high pressure and low temperature in heat exchanger. In heat exchanger, there is a counter current contact of high pressure tube and low pressure tube. Hence, still the temperature air experiences still decreasing temperature in heat exchanger. Now the air is ready to liquefy or about to liquefy. In heat exchanger, the air is ready to liquefy or about to liquefy. Air from heat exchanger, highly compressed air from heat exchanger is fed into a throttling valve or expansion device. See the pictorial representation of throttling device. First, air experiences still more increase in pressure because a convergent section. Once air enter into the expansion valve or throttling valve, first it experiences still increase in pressure due to convergent section. This is convergent section. This is throttle area. This is divergent section. First, the air experiences still more increase in pressure. Once it enter in this region, all of a sudden it expands. Due to sudden expansion, there is a drastic decrease in temperature. The air completely converted into liquefied air, or major portion of the air, compressed air, is converted into liquefied air. Clear? This is the section, expansion valve or throttling valve. Once the compressed air enter into the expansion valve, it suddenly expanded. Due to sudden expansion, the temperature of air gets drastically decreased below its critical temperature. The air will be liquefied. The liquefied air and unliquefied air, the two-phase region, two-phase flow is entered into the flash drum. It is used to separate the liquefied air as well as unliquefied air. Liquefied air is fed into the safe storage tank. The unliquefied air at low temperature again reunited with the cold air, cold outcoming air, and mixed here is fed to the low pressure tube. As usual, what I am trying to say is the working principle is single compression, dual expansion. Only one compression stage. Clear? And dual compression. One is isentropic compression. Another one is isenthalpic compression. Here the expansion is very sudden expansion. There is no suitable mechanism to convert the heat energy into work. There is no suitable mechanism here to convert the heat energy into work. In this expansion, the amount of heat energy is completely utilized to perform the work. So this method is called as external work method of cold production. This method is called as external work method of cold production. Here there is no way to use the heat energy as work. This method is called as internal work method of cold production. This is internal work method of cold production. This is external work method of cold production. This is isentropic expansion. This is isenthalpic expansion. Isenthalpic expansion, isentropic expansion. Single compression, dual expansion. This is the working principle of Claude liquefaction process. Clear? Thank you.